biggest topics, like the things that I've noticed that, yeah, these are pretty crucial. If these make sense to you and you have them memorized, you'll be in good shape to proceed with calculus. So one day of review, and then we get right into the calculus topics. So, here we go. First thing, I wrote on the paper there, number one, I said, what is a simple definition of a function? There is a more complicated definition you've probably heard, which goes something like a function is a set of inputs and outputs where for every input there is a unique one and only one output value. You don't need to know that lengthy definition. I've never seen it tested. I've never seen that you needed to know it to answer an AP question. But what is helpful is to have this memorized. Every time you look at an AP problem, always be thinking, hey, they're talking about a set or a list of inputs and outputs. And that's good enough. We will have a quiz on this stuff on Friday. No homework tonight. Just make sure that whatever we talk about today makes sense. And make sure you have it understood and memorized so you can be successful on the quiz on Friday. So they say, really, they won't even say the word function. It's like you see an AP problem, you should be thinking, hey, I'm dealing with a list of inputs and outputs. Question. What's the purpose of the formula? To calculate the inputs and outputs. And I've never seen a student have trouble knowing that you can take a formula and plug in an input and calculate an output. But I've seen a lot of students get stuck on problems because they're like, I don't know what else to do, and they've simply forgotten that you can do it backwards. You can also plug in an output and figure out what input goes with the output. So make sure when you think of the formula, you think of it both ways. That's where people get stuck. Purpose of the functions graph. I've never seen an AP problem where you had to use the word parabola. So you don't have to remember details like that. But what you do have to remember, and it's super crucial for the next lesson we have on Friday, is when you look at this, don't think of it as a line. Don't think of it as a curve. Think of it as an infinite number of dots. They're just so close together that they look like a nice smooth curve. But they're just dots. And every dot has two numbers associated or assigned to that dot. There's an input value and a corresponding output value. So go over here to 3. There's an input value and a corresponding output value. So when you're looking at a graph, you're just seeing a picture of the inputs and outputs. So I tried to make this easy to memorize. Every time you're dealing with an AP problem in this class, it's just a list of inputs and outputs. You use the formula to calculate either one, and the graph's just a picture. Just looking at the picture of the inputs and outputs. And that, if you can remember those big ideas from years of math, you're in good shape. Like there's not a whole lot more you have to carry forward. The rest just kind of comes naturally without you even thinking about it. So, but this is where people have kind of gotten stuck in past years. So, questions? Perfect. Okay, so next thing. So like on number 4 on that sheet, I gave a formula of velocity. It says v of t equals 5t plus 3. And just checking the whole room here for a second. We're in some tally marks. Just want to make sure everyone's clear. When you see a function's formula like this, this is for the whole class. So everyone who can tell me what symbol is representing the input value and what symbol is representing the output value in this formula, just raise your hand. I want to pay everybody. So if you know what is representing the input and what's representing the output, just raise your hand. Perfect. Keep your hand up for a second. It's really important if you know to make sure you raise your hand. If you don't worry about it. It's no big deal. but I just have to see how the class is doing. So Austin, what's representing the input?
T.
And the output?
V of T.
And I've also seen, either way, I've seen people refer to V of T or V. I've seen it go both ways. So how many knew this before he said it? Show me your hand. So mark down 2 tally marks. Cool. Question. Awesome. So this first question is basically saying use the formula, take the known input and generate an output. So V of T represents the velocity at any time. V of 4 represents a specific velocity when time is equal to 4. So that's using the formula to take an input and calculate an output. Simple example. Questions? And I'm just kind of always watching people's pencils. I really hated when a professor would go faster than I could think and write. So I just kind of watch when you're taking notes to look for a pause. So. 5 is asking the opposite now. Same formula, but instead of knowing the input, we know the output value. But we can still use that formula, substituting for an output to calculate the appropriate input. In this case, we've got to use a little bit of algebra to rearrange the equation. But we determine that when the time is 10, that would give us the velocity of 53. So. Question. It's pretty simple, but it really is interesting how when we really get into AP problems, how many people get stuck. Like they'll be working through the problem and they get to the point where all they have to do is say, wait a minute, I've got a formula, I know the output, I can find the input, and they just don't think of it. So that's why today I'm just saying this is pretty big. It actually comes up a lot throughout the year, even though it seems simple today. I would memorize this statement right here. You're going to be asked as you solve AP problems. They won't say solve the equation. You just have to think of it yourself. But if you're working on the section of the test where calculators are not allowed, you'll be using this method where you plug in the known output, do some algebra, find the input. If you're working on the section where calculators are allowed, you don't want to do this because it takes time. Usually the formula is much more complicated. You want to do the second method. Graph both halves of the equation and find the intersection. So on the calculator allowed section, you definitely want to be doing this because they'll often give you an equation that cannot be solved by hand. They're forcing you to know how to use your calculator. So when I say graph both halves of the equation, here's what that means. Grab my calculator. I draw one graph, which is the right half of the equation. Let's go over here. It's over here. Then I draw the other equation, which is the left half. And then I simply plot them. It's just a bunch of dots. Here's the dots that represent the formula. These dots all have an output value of 53. When they intersect, I know the time is 10 and the value of the velocity is 53. So I find the intersection. Any questions coming to mind from anybody? Perfect. So that's crucial. I have a set of notes that I give you before you get ready for the AP test. This is on that set of notes because it comes up enough that you want to make sure you don't get stuck here. So. Cool. We're watching for notes. A minute. Also, whenever I say questions, for my personality, you don't have to have a question. This is pretty straightforward, but anytime we're talking about anything, if you just suddenly start to feel like, hey, I'm getting a little bit lost, just raise your hand and say, can you say it differently? Can you give a different example? I'm just feeling a little confused still. You don't have to form a question. Just tell me to stop. If I ever forget to kind of check for how fast you're keeping up with the notes, just raise your hand and tell me to slow down. It doesn't bother me a bit. So. Okay, next one. So, just to get a little bit of interaction here. Number 6 on your sheet, it's also displayed here. So here they don't give a formula for the function. They just give a table. They actually give you a list. They say find g of 1. What I'd like you to do is find what g of 1 is. So that means g of 1 is equal to something. So they're giving you an input value and asking for an output value. I'd like you to show on your hands what belongs here. So just show me with hand signals what belongs right here. Just checking your creativity here. I've seen people do negative signs like this. I've seen this. I've seen, hey, if I put it upside down, maybe that means negative. So you can't really turn it like that. But, and I really do check your hand signals. So if you're not doing the hand signal, you don't get the tally marks. So just want to make sure you're with me. You're not checking out on the conversation here. So if you're doing something like this, or I don't know which way it goes, give yourself 4 tally marks, please. Solving an equation means find the value which makes the equation true. So we're looking for the value of x which will make this a true statement. So show me on your hands what value of x will make that a true statement. Just checking. You can just kind of conceal your answer here so the whole world can't see you. Be like all secretive. And that way I can kind of just check and make sure everybody's with me. Everybody's drifting off. So. Cool. So give yourself 2 more tally marks. Question. Outstanding. Next one. Okay, this is just kind of it's just an example of, really simple example. They get far more complicated, but on the AP test, it's very, very rare to have what I would refer to as a naked problem, where there's no story, there's no context, it's just, here's some equations, do something with them. Very unusual. Almost every question is a little puzzle, a little story, a little situation. So this one has no calculus, of course, but I just want you to work these 2 problems quick just to kind of get used to the type of, at least get started on the kind of thinking you're going to have to do in this class. So, as I walk by it, some question pops to mind, just stop me. So use your hand to show me what answer you got for number 8. Just secret answer, right? Use your hands. Most people giving the standard method of indicating 6. I was looking for a few creative ones. Yeah, that works. So just a little reminder here. On the AP test, I'll remind you of this throughout the year. On the AP test, if they give you units for a problem, they will very often require units in the answer. Best I can remember, they always give you a little hint saying, oh, don't forget the units, but if you just develop the habit of always including units when they are in the problem, then you won't lose out on points. So 6 feet there, give yourself 6 tally marks if you have that. And I designed a really dumb problem because the answers are the same numeric value, just different units, but oh well. So 6 seconds there. You need me to talk about either problem, just wave at me. You don't actually have to ask a question, just give me some sort of signal. Cool. Cool, next one. Okay, so back to the function. Another thing you have studied for years actually is average rate of change. You know it as the slope of a line. It's another way to think of it. For our class, you need to start calling it the secant slope. So average rate of change and secant slope. It's also really important that you not just memorize a formula, but that you make sense of the idea. Don't just memorize a formula, like make sense of what they're talking about. So when they say average rate of change, they're saying, for example, right here, the input value of the function is 1, and the output value of the function is also 1. As you move to a different place along the function, a different set of xy pairs, for example, if we went to this spot, we would find that the input is 3 and the output is not 6, 9, sorry. The output is 9. Average rate of change means, on average, how fast are the values of the function changing from value to value? So as we move from this dot to this dot, on average, how much did the output and input both change? So if I'm trying to find the secant slope, or the average rate of change, I note that from this input-output pair to this one, the output is changing by 8. The input is changing by 2. So that's my average rate of change. When the input changes by 2, the output's going to change by 8 on average as I move from here to here. Please, Sarah. Right here. It would help if I went to the right place. Yeah. So, Sarah, please mark down 4 tally marks. But that's my mistake. I would have asked the same question, since that's a 7, not a 9. Simply an error. Sorry about that. I just went up the wrong part of the graph. So this should have been here. That would have made better sense. Agreed. How many noticed the mistake before Sarah raised her hand? Give yourself 3. So. Sorry about that. Other questions? I wish I was really good at actually making mistakes on purpose. I'm just not good at it. It just happens. It'd be a lot better if I could make them and like watch and see if you could notice the mistakes. But anyway, anybody else? Perfect. Note for the AP test: you don't have to do any reducing, simplifying of anything. If they said find the average rate of change and you wrote 8 divided by 2, full credit. If you decide to write 4 divided by 1, still full credit. If you decided to write 4, still full credit. I'm going to encourage you in most problems, not all, but in most problems to stop here, because there's no reason to risk simplifying, especially if it's complicated. All you're doing is extra work, takes extra time, and you don't get any more points. So you might as well stop. Cool. Average rate of change is the same thing as the slope of the secant line. So if I try again, if I draw a line between those points, that's still not very nice. I'll just sit here for about 5 minutes while I try to draw a straight line. It's still curved. It's bothering me. It's still curved. There we go. All right. Well, Yeah, more or less, thank you. So that secant slope is, and I will often write all rates as a ratio to emphasize you're always talking about two things simultaneously. When they say find the average rate of change, it's saying how did the input change relative, how did the output change relative to the input, always. Question? Please. McKay Goodman. I'll do both names for all to make sure I get it.
So, on this example, from 1 to 9, the difference is phase. But if we were to do 0 to -9, would it be 9 or -9?
Oh, well done. So, if we go, I don't have it on the graph. Because you're always reading the graph from left to right, you would say that from the point over here, so you're comparing these points. 3, -3, comma 9, correct? And 0, comma 0. So the way you're expected to read the graph would be, as I move from this input-output pair to this one, the output is dropping by 9, so the average rate of change, I just use my own little abbreviation here, that's not official. Average rate of change is going to be the output went down by 9, while at the same time the input went up by 3. Yes. So the average rate of change is really -3/1. Is that your question?
Yeah.
Yeah. Please.
So is the output always over?
Well done. So take 3 for McKay and 3 for Shirley. Yeah. For our class, they never switch it around. It's always how is the output changing relative to how the input is changing.
Do they use like input and output as words on the AP test a lot?
No, they expect you 3 tallies for that, Ryan. Dang. I have to pay for the wrong name. Reed Olson. My apologies. No, they won't. I don't think I've ever seen a problem where they actually use the word input and output. They just expect you to look at the problem and think, oh, this is the input values, these are the input values, these are the output values. Like you have to recognize that. Is that your question? Yeah, it's perfect. Anybody else? Oh, please.
How much of the AP test is review from past years? Is it a lot?
I would say hardly any is review from past years. There are a few things that you've got to carry forward, like what we're reviewing today. A few other things we just kind of pick up as the year goes on. But I wouldn't stress heavily about, I've got to go back and review lots of old things. I really am very confident you can get a 5 if you can just focus on what we covered this year. And I'll just kind of roll in the things like, oh yeah, remember you studied this? Yeah, you got to remember it, that sort of thing. So, is that your question? 3 tallies, job, right. Okay, next thing. So work this out for me. So just answer that question, please. Just again, stop me if you want to ask anything one-on-one. So. So if we look at the function from the xy pair at 0 to x equal 10, we see that the output is dropping by 25 over that interval, while the input is increasing by 10. That's what average rate of change means. How much is the output changing relative to how much the input is changing? So again, don't memorize the computation, memorize the idea. That's what's going to be important. Sure, please.
So normally with fractions, it doesn't matter if you like put it out to the front. With these, if it's a negative for the out, like how it's negative 25 over 10, we also write it as like, okay.
You're perfect. Put down 3 tallies, please. I think this is what you're asking. Is that correct?
Yeah, I just want to make sure that we're like.
Yeah, any of those are fine. Yeah, whenever you have a fraction, if the numerator or denominator is a negative, now if they're both negative, it becomes a positive. But if either one is negative, you can write the negative with the numerator. You can write the negative just out front of the fraction as a whole. You can even put it on the bottom. It doesn't matter. They're fine with either of them. It's a good question. Anybody else? Please.
The best way to find the top, would it be just to look at the values of the first and the last one, or would it be better just to do like the solving between the two numbers?
Speak a little bit more, Mason. I'm not sure what did you go on.
So, not sure.
You're okay. You can give an example of what you're thinking.
Like taking just 5 and just 5 and 20 and sort of going, like just putting those two together, like adding.
Oh,
5 and 20.
you can do it that way as long as you pay attention to the signs. There's nothing wrong with that. If you can kind of visualize it as, hey, this is a positive 5 value, this is a negative 20, so you can kind of think of it as a number line if you want, and go, oh, the space between them, the change is going to be 25.
Okay.
For sure. It's critical to make sure, because you will lose the point if you get the positive or negative wrong.
Yeah.
But yeah, you could just look at it and say, oh, I can see that the output value was a positive 5, now it's a negative 20. Oh, that change was a drop of 25. Is that what you meant?
Yeah.
3 tallies is perfect. That's nothing wrong with that at all. I do it that way all the time in my head if the numbers are pretty simple. If the numbers become kind of messy decimals or whatever, I'll grab my calculator and work it out as a difference, a subtraction, but you don't have to.
Okay.
Please.
So is that equation on the top, can you use that for all of them? Like even if both numbers were negative?
Right here. This, absolutely. This is simply saying this symbol represents the output of the function when the input's 10. So you're taking the output value minus output value to find, because change means the same thing as difference. How much are those outputs changing divided by how much the inputs change? Is that what you meant? It's perfect. 3 tallies. Please.
Should we always keep it in fraction form if it's not necessary to go into decimals?
Kind of up to you. Really doesn't matter. If you just naturally, like I wouldn't worry about, how should I say, there's no need to stress. Any of these are perfectly valid answers. They'll accept any of them. I stop because I just have the habit of just generally saying, no need to go further, why risk another mistake? So I just stop there. So. On a multiple choice problem, you sometimes have to go farther because you've got to find their answer. Does that make sense, Len?
Yeah.
Perfect. 3 tallies. I got to slow down on the tallies. If you find myself giving you 1 instead of 3, I apologize, but I just get a little excited as I stand at the front of the room. Just distribute extra credit like it's falling from the sky. So, raining down. Someday I'll I'll install equipment in the ceiling. It'll be much more fun. Just push a button and Miranda can just catch the ticket as it falls. A sweet classic. It'd be pretty cool, actually. Anybody else? Cool. All right, next one. Just work this out real quick. Go. Stop me if you want to talk about anything. Table's always blocked.
Mr. Smith,
Yes.
could you send Sarah Richter to the front? She'll be checking out.
Okay.
Thank you.
Please.
When you say to work on a problem, do you want us to work on it alone or like with the people?
Oh, gotcha. In class when we're having the discussion, what I think is best is do it yourself as much as you possibly can. I think you actually learn better to do that first. But then for sure compare, doesn't hurt a thing. If you feel like you're stuck, you want to just ask, hey, is this the right approach? Totally fine as well. So always get as far as you can yourself first, but you're totally free to talk to whoever. So. Please.
So like for showing work, what are like the requirements as far as testing and like versus homework?
I will give you some pretty good guidelines once we get into some homework and things like that as far as what I feel like is necessary to show. And what I'll be giving you is what they're going to be requiring on the written portion of the AP test. They aren't, how should I say, in most cases, they're not really very strict. They simply expect you to use the equal sign correctly. So as you work down the page, show that, hey, this is equal to this is equal to this. You can skip a lot of steps. You don't have to show everything. In certain problems, a certain amount is required to be shown, and I'll just keep reminding you of that. So it's kind of case specific. So just based on the problem, I'll say, hey, this type, don't need to really stress much, skip as many steps as you want. This other type, you got to show this amount, that sort of thing. So not the best answer in the world, but I'll guide you with that one. So 2 tallies for Jonathan, 2 more for Reed. Anybody else? Cool. Next thing. Okay, you've all studied logarithms. You do not have to remember a ton of detail about logarithms to get a 5 on the AP test, but you do need to remember a little bit. So just as kind of a quick review, I've never seen a log-based 2 problem ever on the AP test. A log-based 2 is a good choice to kind of help you remember what things mean. So I'm going to write on the board log-based 2 of 8. And you have to make sure you're always using the equal sign correctly. So log-based 2 of 8 is equivalent to something. And what I'm reminding you of is when I see that, my brain is actually thinking the following. I'm paying attention to the base, which is 2, and I'm remembering that log base 2 means 2 to some unknown exponent will end up being this number. That's how I work out a log. If it's more complicated than that, they'll let you use your calculator. So it's not like you have to do complicated log expressions. No one expects you to do that without a calculator. But they do expect you to be able to reason through something like this. So just show me on your hand what belongs here. Just show me on your secret ballot what belongs here. So 2 cubed is 8. Therefore, the log base 2 of 8 is 3. If you were showing 3 fingers, please give yourself 3 tallies. So. Questions? Does that make sense? Do this one just to make sure we got it, plus then you get some more extra credit. Everyone's hoping for the log base 2 of 1024, but yeah, a little high. So tell me what belongs here. Just use your hand again. Secret ballot. So your brain should be thinking 2 to some number will result in 32. If you can't think of it, I just count it. I go, let's see, 2 squared would be 4. 2 cubed is then, so 4 times 2 is 8. I just count it out until I get it. Show me. If you're showing 5 fingers, give yourself 5 tally marks. Questions? Cool. Again, I've never seen a problem that used log base 2. What is most common is log base E. In fact, I don't think I've seen any other kind of problem on the AP test. So if I write log base e, but pretty uncommon to write it as log base e. Much more common to write it as just natural log. But they mean the same thing. So you will work a calculus problem where you'll suddenly encounter something like this. And you've got to know what this is equivalent to. So log base e, the base is e. So in my head, I'm thinking e to some exponent has got to end up being this value. So log base e means do this in your head. So show me in your hands what belongs here. So if you're doing this, give yourself another tally mark. Question. Cool. Let's do this one. So you're thinking, because it's natural log, it's e to some exponent has to end up being 1. Show me on your hand. So what belongs here? So e to some exponent has to end up being 1. If you're doing this, give yourself 2 more tally marks. E to the 0 is 1. So natural log of 1 is 0. This kind of thing needs to come out of your head about as quick as a multiplication problem. Like you're working a problem, you suddenly got to do 7 times 8 is 56. Same thing. You see natural log of e, you just got to think, oh, that's 1. Natural log of 0, natural log of 1, that's 0. It's got to be that quick. So you don't let this get in the way of solving the actual problem, the calculus part. So, questions? Here's another one I've seen appear on calculus tests. Algebraic property. 1 over x to any exponent is the same thing as x to the negative exponent.
Yeah.
Okay? So I've seen this happen. You have to figure out the natural log of 1 over e. So you first have to remember that's the natural log of e to the negative 1. So these two are the same. So then you have to think, okay, if I'm finding the natural log of e to the negative 1, that means my brain's over here thinking, it's thinking e, because it's natural log, to some exponent is going to become, and it seems like a trivial problem, but that's how you think of it. So this is negative 1. Question. So earn some more tally marks. Don't overthink it. Just show me on your hand what belongs here. Natural log of e squared. So if you're doing this, give yourself 2 more. Because your brain is thinking, okay, not a big deal. Natural log means e to the what? So e to the what's got to become e squared. That value has to be 2. Questions? Please. Uh-huh. So really, key thing is whenever you see natural log, just make sure, those are kind of large. Oh well. Whenever you see natural log, just convert it. So if I write natural log of e to the 5th power, my brain says the natural log part, that means e to something. So my brain's over here thinking, okay, e to the what is supposed to be this. So now I know that it's 5. That makes sense?
Yeah.
2 tallies. Anybody else? Cool. Here's some formulas. Write them down. You'll need to have them memorized. You memorized them before, but these do show up once in a while in an AP question. This is the one we've been dealing with right here. Natural log of e to any exponent is just the exponent. So. So this is some properties that you've learned previously that they won't give you any hint. You'll just be working the problem and suddenly you'll see something like this and you have to remember back. I'm just watching everybody's pencil to see if we got anything out. Okay, another thing that will happen as you're working an AP problem is you'll also get to a point where you suddenly are faced with determining an equivalent value for, say, oh, I don't know, the sine of 7 pi over 6. Some people suddenly think, oh, I've got to draw the entire unit circle to be able to solve this. I personally don't recommend that. I think it's fraught with error. I think it's a lot better to say, oh, I just need the sine of 7 pi over 6. So I still draw a circle. I can do it mentally. I don't have to do it on paper any longer. But what I'm doing mentally is I'm counting. So here's my circle. I've got to get to 7 pi over 6. So here's 1/6, that's 2, 3, 4, 5, 6, 7. So that's the spot I'm interested in. To get to that spot, I would come over from the origin a long distance, and I would go down a short distance. I have memorized that the short distance is always root 1 over 2, or 1/2, and the long distance is always root 3 over 2. So now I look and say, oh, sine is always the up and down, because it's the y value, cosine's the back and forth. So this is equivalent to this amount, but because I had to go down, it's a negative value. That's how I do it. And you will do this once in a while on an AP problem where just you have to figure out something like that. You don't want to get stuck on it. Again, it should be like your times tables. So, questions? Please, Jonathan.
For like sine 4 pi over 3, the distances you would use is that square root 2 over 2?
Nicely done. Hold on a second. Can't do it that quick, so just give me a minute. 4 tallies for a really good question. 4 pi over 3, I have a hard time doing the thirds. I make mistakes. I can't visually see the thirds very well in my head or on paper. So what I would do is draw my circle, and I would count 6. And I'm so excited about the question, I'm going to give away a bunch of tally marks. So if you can show me on your hands how many 6 are there in 4 pi thirds, I'll give you tally marks. How many 6 do I count if I'm trying to get to 4 pi thirds? How many 6 do I count? Show me with your hand. showing 8 fingers, put down 8 tallies. 4/3 is the same thing as 8/6. So I count 8. So I go 1, 2, 3, 4, 5, 6, 7, 8. And now I see what I'm looking for now. The over distance is short. The down distance is long. So that's the down distance, which is root 3 over 2. Because I went down, it's negative. Is that your question? Yeah. Oh, please.
Should we always try to convert like the fraction so that it has a denominator of 6?
I do. I think you can leave it as thirds. You really can. I just make mistakes, so I always count 6. If it's fourths, I just count fourths. If it's halves, I just count halves. But I don't ever count thirds. I just count 6. 2 more for 3. Please. I wouldn't. I really wouldn't. I wouldn't memorize the whole circle. All I would do is what we're doing here. I just draw the picture, I count. I can see that I've got a long and a short. You do have to memorize that the short's always 1/2, the long's root 3 over 2.
What do you mean by long and short?
Oh, sorry. Just visually. Are you okay on how I counted to this spot?
Yeah.
Good. When I get to the spot, I draw a horizontal line over from the origin and a vertical line to get to the point. So basically walking to the spot from the origin. One of the lengths will be long and one will be short. Anytime you're doing sixths or thirds, that always happens. So whenever we're doing sixths and thirds, I know the answer is going to be either 1/2 or root 3 over 2. Either the long value or the short value. If that makes sense.
Yeah.
Still with me?
So you got the negative
Because I had to go down. So let's do a couple more. So like if I had to find the cosine, 3 for Shirley. If I had to find the cosine of 7 pi over 6, I'll have you help me, Shirley, just to make sure it's clicking. So the cosine is the back and forth distance. So is it the long or the short? The long, because it was the back and forth distance. So that's root 3 over 2. Did I move, so from the origin to this point, was my back and forth in a negative direction or a positive direction? So now I know this is negative. So I don't memorize the whole circle, I just memorize that little process. That's what I prefer. I think it's easier on your brain. But you're free to memorize the whole thing. Does that make sense?
Yeah.
Help me with one more, just real quick. So over here, if I'm finding the cosine of 4 pi over 3, so that's this spot. Cosine's the back and forth. Was that short or long? Short. So it's the 1/2 value. And then I go positive and negative back and forth. Negative. Perfect. You're welcome. Anybody else? Please.
So for the 7 pi over 6 example, would it matter if you went down first and then to the left?
Mm-mm. Yeah, it doesn't matter. You can think of it this way, Reed. It's perfectly fine. So I could have thought, oh, I go down and then over. So the down is short. That's the sine value. The over is the long. Yeah, the order doesn't matter. Please, John.
Are we ever going to have to deal with problems like 7 pi over 12? That can't really be.
Gotcha. 2 more for each of you. No. Without a calculator, the only values they expect you to recall from memory are halves, like pi halves, thirds, and sixths. Oh, and fourths, sorry. That's it. So no need for anything else. Anybody else? Cool. Let's do a couple more just to make sure. So if I go, let's see, cosine, we'll do 7 pi over 4. So I think of a circle. That's a good circle. Sit down and admire from you. Come back here. It's better. That's a little squashy. Oh, I'm not worthy of a picture. So I count 1/4, 2/4, 3, 4, 5, 6, 7. So that's the spot. Now back to what Shirley was asking about, what do they mean by short and long? At the fourths, the distances are equivalent. So the over and the up and down are exactly the same. And they're both √2/2. So the pattern's easy to remember because one length is √1/2, that's the short. The medium is √2/2, and the long is √3/2, and they go in the order you would expect. So these are both √2/2. Cosine's the back and forth, so it's over, which is to the right, which is positive. So this is √2/2. The sine of 7π/4, that would be equal to negative √2/2. If it's not clicking, just ask. I can do as many examples as you want. If you get your brain to just understand the process, then it's no big deal. You just think of the circle, count, long, short, positive, negative. Please.
Because the AP test is timed, would you think it's better to like memorize the unit circle just so that you can recall it like super quickly, or do you think this is like it doesn't take too much time to essentials?
Gotcha. Everyone's different, but I actually think for myself, I still wouldn't memorize the whole unit circle. I would just get good at this process, and I'm good enough at it now that I can do it mentally. I can just picture a circle and go, got it. So I wouldn't memorize the whole thing. I think you end up kind of clouding your brain with stuff it doesn't really need. Hold on, I gotta get the name. Grace Collister.
Yeah.
Okay.
Okay, can you show me again how you divided it into like the 4s and then you counted to 7?
No worries. The thing that's weird about the circle is that from here to here is pi. So 1/4 of this much it's really like a pizza or whatever. So 1/4 is only that much of pi. So that's why this is 1π/4, if that makes sense. And then if I cut that much again, now I've got 2/4. So here's the 3/4, and then this is 4/4 or pi. So then this is 5, 6, 7. Did that make sense? 2 more tallies. Pretty out. Outstanding. That's enough to get us started. Like, we don't really need to review much else. Next time we'll do a little bit of review on factoring, but just in the context of the calculus. I find it way better. It's just so boring to, like, for all of you to just go back and do things you've done again for day after day. It's way better to jump into something new, and then as we need things you've learned previously, we just talk about them. So that's it for the review. We have enough time to do one little extra credit thing. So we don't do this every day, but once in a while we end up with enough time. So